Hello and welcome to our alveo webinar on Wednesday, the 27th of August. My name is Christian Remus. I'm the Product Manager for alveo. I'm not alone. With me and later for the Q&A session is Matthias, our project lead, our engineer, main engineer for this project, and he will also be there to answer questions. I'm really excited to show this today because we've been working now for more than 1.5 years on this project. And it's more demanding and more challenging than we thought at the beginning. But I think from all we did until today, even if not everything's finished, we have a really revolutionary product to start with and to be released in October. And I would just like to start with general information about the alveo, about the technology in a short presentation. After that, we will have a walkthrough through the whole UI with all the things alveo can do today. And later on, we will also have a little glimpse of the physiology model we have built in, but we'll talk about that later. Okay, so let's just start with a presentation. What is alveo? For those who may be not too familiar, haven't seen alveo in the past trade shows or congresses, alveo is a new lung simulator we designed, and IMT and IMT Analytics, but mainly IMT is an engineering company who is also in the past years developing ventilators. And the engineers were always a little bit struggling with the lung simulators that are available today, because some things, especially when you're working on NIV ventilators, can't be simulated in a way that it is realistic, mainly leakages, or you need some DIY solutions. So they were thinking about a concept that will improve simulation, especially when developing ventilators. And over time, this grew and grew, and there were also some patents filed for this. And then when we saw what this can do, the idea was there to also market this product. It was not meant to be as a product to be marketed in the very beginning, more than an engineering tool. But now it is a product, and we did also some thorough market research, and we surely hope that everything what alveo can do when it's launched in October will serve your needs. Technology is one of the main parts, which is different from other simulators nowadays. When you want to simulate a lung, you need two components. You need something to do the compliance, or to simulate the compliance, which is you apply a pressure and then you have a volume change. And you need a pressure drop in the airway to also simulate the resistance. There are many, many more pieces to that, but these are the main components. And to date, most of them are used with a piston-based closed chamber or with a bellow, and they work well. So they do what they have to do. You can adjust this very, very accurately, and this works, but this is all has contained volume, and so leakage and other things are not easy to simulate, because the air that goes in must somehow go back out again. And so the idea was to make it really, really different from any other simulator we have today. So the idea was that we have an inlet port like any other simulator, which would mean the connection to the tube or the mask of the patient, and then there is a resistance valve which is doing the resistance, and then at the end there would be a turbine blower, which would push against the airflow coming from the ventilator or from the bag or from the anesthesia device, and so also simulate in very easy, not engineering terms, the compliance as well. The air is not contained in the simulator. That makes it possible to build this very compact. The air goes out to ambient, and so we now have a close look into alveo. So we see here on the left the flow port where you connect the ventilator. Here is the flow and oxygen sensor module, which is measuring the oxygen concentration of the incoming gas and also measuring the flow. The oxygen sensor is a maintenance-free optical oxygen sensor, so you don't have to exchange this sensor as long as the alveo, at least for 10 years, as long as the alveo is running. After this flow measurement unit, you will get into the resistance unit, which is a valve system, which opens and closes. And this was quite challenging to do because we have a very large range of resistance settings. We start with 5 and go up to 500 millibars per liter per second. After this, there comes the first turbine blower, which we call the main blower, and he's doing the compliance part and is also pushing in the expiration phase the air back to the ventilator. And then there is a second blower unit because we also need to do spontaneous breathing, and the second blower unit is in reverse and is triggering and doing the muscular effort or the muscular pressure on the ventilator system. And they are coupled together, and there is another bypass valve to keep the resistance low in the whole system. And we see also the airflow. So this is the whole system here. You see the cooling flow goes through the whole simulator and then also cools the turbines and goes out on the other side. And what I wanted to show you is that this is the bottom of the simulator of alveo, and this is the air coming from the blower, which is going out to ambient. And this is what we call the floor exhaust plot. Looking at the alveo, we have on top certain status LEDs for the Wi-Fi connection. You can use this device with the controllers wireless and also wired. You see the battery status. The alveo offers an optional battery for 3 hours of simulation when you do not have a power source, and you also see the device status if the simulator has started up correctly. And this is the field. This is how it looks like. So these are the LEDs. So this is the wireless, then we have the battery, and then we have the status LED. Then we have a device handler where you can move or carry alveo around. Alveo has around 6.8 kilograms, around 16 pounds. So it's not feather light, but it's transportable. You can use it as a portable device. And there's also in the device handler a tablet rest, so that you can put, for example, when you're in the back mode, you are standing in front of the alveo, you can do and put the tablet just in front of you, so you immediately see what you're doing when you are exercising with alveo. Then we have the air intake. Here is the flow port to connect with a ventilator or bag, and this is the air exhaust. The whole system is very, very compact, so it's always a little bit surprising when people see alveo in real, that it looks much larger on the photos than it is in real. And then on top we have the lung view. This is an LED panel which is also showing the settings on which alveo has been set to in terms of compliance, resistance, and spontaneous breathing. And this is synchronous with the incoming air from the ventilator. So you really see a movement of air in and out, and you also see the compliance and respiratory status and resistance status of the patient. These are the interfaces on the back. So we're starting with that you also you're not supposed to use the tablets all the time. You can directly hook up with a PC and write your own script in remotely controlling the alveo. We also have a CAN bus, which is mainly in our internal interface for debugging and for maintenance of the device. We also have a on-off button, but there is also Ethernet connector, which I probably have forgotten now, but this is the Ethernet connector, so you can also use alveo in the LAN. This might be very interesting for automated testing or when you want to use more than one alveo at the same time, so they can be connected together. Here's the battery compartment. Here is the power connector for the power supply. And then we have two USB connectors for the control units for the two tablets you can alveo use with. They are for charging. And when you don't want to use the whole system wireless, you can also use them when you have wired connection. And then on top, we have two additional interfaces for upcoming modules. You already see something. Actually, we're calling them COM1, COM2 now. But later on, there will be also an artificial SPO2 finger. So for closed loop testing or for closed loop training, you could put an SPO2 on it. And we're also looking for an esophageal pressure module, which can also mimic esophageal pressure. And so you could also train your ventilator training with esophageal pressure measurements coming from the ventilator. The battery, you open the battery lid and then you put in the battery. For all those who are using our ventilator testers as well, it's the same battery the Flow Analyzer Pro is using. And in the Flow Analyzer, the runtime is a little bit higher, but since there's a lot of turning parts in alveo, it's around 3 hours, but this should give at least some room for some lessons, maybe also outside the building if necessary, so you can use alveo without a power source. This is the bottom view. On the bottom, there is what we call a silencer, and then there's also filter mat. And so this can be put together on the bottom, and later on you can also put an adapter to it if you have maybe some gas measurements and you want to have the gas returned. So we are also working on an adapter for that. The lung view, as I said, visualizes the compliance, resistance, airflow, also some incidents. So if you would have a pneumothorax, it also could show you that one half of the lung or one arch is dark, so this lung part is not functional, but also compliance, resistance is shown in different colors. Green is very good, yellow is moderate bad, and then we have also severe, which is red. And same for the effort, a red effort or a red arch on the bottom would also show a high muscular effort coming from the patient. This is the scope of delivery. So you have the main unit, you have the two tablets. One is called the educator or the control tablet. The second one is the student or vital signs tablet. And then you have the power supply, you have an adapter, a bag of adapters, depending on what you want to connect with alveo. Then you get the two USB cables, you get a quick start guide, which also leads to the IFU, and you also get an ISO 17025 certificate when alveo is delivered, for calibration certificate when alveo is delivered. The setup is very easy, so you can have it either wired, so you just connect the two tablets directly with alveo. You start the tablets, you start alveo, and then they find themselves, and the vital signs will be shown as soon as the physiology model is activated, and the controller will start working immediately after startup. But you can also just start up the tablets, not have any physical connection to alveo, and they also find themselves via Wi-Fi. So it's not a Wi-Fi where you're also connected to the internet. It's an internal Wi-Fi, and so they will always find themselves. Later on, we may open this also to an internet connection when you want to use it in an internal hospital Wi-Fi. This is the configuration. Software updates, the tablets will be updated, or the tablet update will be happen via cloud, so you will be notified that there is an update available. Then you have to type in your Wi-Fi, and then the update will be done automatically. You just have to restart your tablet. and the update of the device itself will be done by USB. You start up the alveo. Takes around 60 seconds until alveo is ready. You will be notified as soon as the lung lightens up. Then alveo is ready to start. There is an internal startup process where we do a self-calibration, and you do the same this either with the tablet if you don't want to use the physiology. If you just want to go on manual, you don't have to open both tablets. And also, by the way, you can also have a mixed usage. You can use one wireless, you can use another one wired. So maybe you have to charge one tablet, just plug the tablet into the USB cable. There is no interruption. It will just be charged, but the whole process will go on. It's very seamless. And when you have started up your control tablet, you will see this. You will see the mode selector. You can start with a lung simulation. You can also go into the configuration menu if you want to adjust something. I will show this when I have the walkthrough. And you also have the bag simulation mode. You can choose. This is the connection. So either you put a bag directly to alveo, or you put one single limb, dual limb, whatever kind of limb. You can also use humidified gases when simulating. This is possible with alveo. Okay, now I will change to the live view. So this is what you see when you have started up. If you need to do some configuration changes, you want to enable Wi-Fi, disable Wi-Fi, do some settings in terms of units. This can be always done before you start your simulation, or if you just want to check, you also can go into the service login. That's also possible for biomeds who need to do the maintenance. And we would decide to start with the lung simulation mode. And it's already connected to a ventilator, and this is just a little bit of flow which is moving back and forth. So this lung is currently a little bit nervous. So what you can do now, you see this table here. So you can start with editing patient information. You can choose between adult and pediatric patient. You can choose, when it's an adult patient, between male and female. You can also adjust the height of the patient for the ideal body weight, which gives some information about compliance and resistance of these patients. And you later, for the physiology, when you want to start with the physiology, you can also adjust the age, because with the older patients get the lung properties, and also the rib cage properties are changing as well. And this is also taken into account. Same with the weight. Because usually we are calculating the ideal body weight with the height, but for metabolism calculation, we also need the actual height. And so you can really adjust from the left to the right. You also see when you have your finger on it, you can see there is always a certain range. So it's not possible to have a patient which is 1 meter high to give them 120 kilo. Because the physiology is not calculating such, how would you say to this, that it's not really realistic. So it's always in a range where it could be realistic. We are also aware that there are very small patients who have 600 pounds, and we're working on that to also have this into here, but we're starting with more or less realistic ranges. We keep that closed for now because we go in manual mode, and I can show you what we can all do in manual mode. So if we activate this later, we can see what happens with the vital signs of this patient. So now I can go into the library, and here I can decide between a normal patient with a normal lung function, healthy patient. I can just decide if I want to give a low effort, spontaneous breathing, a normal effort, or a high effort. And it also shows you the parameters, where they're coming from, what the regular or the default parameters are, and how they change depending on if you put in a low, normal, or high effort. We can also go to restrictive. Not all pathologies are implemented right now, but there are always the same pattern. It's a mild, it's a moderate, it's a severe pneumonia. We have COVID, mild, moderate, severe, and we also have ARDS, mild, moderate, severe. It's always the same pattern. You choose the moderate one, then you can decide if you want to give a low spontaneous breathing effort or a high effort. And the same would be with COPD or obstructive patients. So we have the 4 stages of COPD. We have emphysema. Later on in restrictive, there will also be fibrosis and some other pathologies. And there will also be a little bit more in the normal section. We are just starting with a normal patient. Since we're in manual mode, this is just the default setting where the simulator is starting with. So what you can also do, you see here profiles. You can either manually adjust profiles, and when you open the main menu, you can say, okay, I made quite some settings. I want to shortcut, and I call them, for example, AR. No, I have to put this on the tablet to select before, and then I call it, and then it's saved. And now I can always shortcut a profile, and this profile will also be in the library, not only in this section. So I close this, and at the end, before you start your simulation, you have a summary of the settings you have chosen. That the mode is currently manual because you haven't activated the physiology. And I'm also starting the ventilator. And now I'm starting the simulation as well. So what you see now, we have some curves here. We have a airway pressure curve. We have a flow curve. This is a combination of a curve with a leak. We come to that in a minute. And we have a volume curve. We haven't implemented all of the monitoring values, but at the end, I think we end up with 35 monitoring values about simulation, also ventilation parameters, patient parameters in parentheses. So you see them all here when you open this tab. And so you can look at the parameters, and you can also configure them in the main monitoring area. You also will have certain lung parameters like resistance, compliance. They will also be shown as a monitoring value. And if you want to adjust your main monitoring area, you just activate the editing mode. And then if you want to put the volume, you just move the volume there, and then you have change between volume. If you want to have 2 large tiles, then you can just move this one here, and then you have 2 large tiles, but you can also have 8 small tiles. So it's very easy to edit your screen. And if you go here, they're always the same values, but for now, this doesn't matter. So I put them here, and I put 2 others, small ones down here. And so I can configure my screen and press apply, and then I have configured. Same goes with the curves. Can edit the curves. Here are the curves which are available. Currently I have 3. I can also remove 1 curve, then the 2 remaining ones get bigger. But if I want to put back the volume curve, I just drag and drop it where I want to have it, and then the volume curve is back again. I apply, and so I can edit the curves as well. So we are looking at the top that this is now this patient. We are in the lung simulation mode. It's a normal lung condition patient. This is the educator control screen. This is the time. This is the battery of the tablet, the charging situation. This is connected with the main unit. And when you start a simulation, this will also be a timer which shows how long the simulation has gone so far. When you open now the settings panel, you see that these are now the settings which everything is about. So we have 2 drop-down lists on top, and now we can adjust the compliance of the patient. And as soon as you touch this slider will be highlighted, so you know you have changed the value. And you can go down one by one. But we have a very large range of compliance between 3 to 300, and this might take a minute. But if you just stay on the slider, Then a keypad will open and you can directly adjust the compliance. And maybe we go down to 20 and put up the resistance a little bit, go out to 15. And as soon as I apply, you will see some changes here on the curves, but it's immediately done. So whatever settings you want to change, it will happen very quick and very fast. And if I now would adjust some settings on the ventilator, I can show this to you with a different screen. So now this is the ventilator. I've adjusted the PEEP. I adjust the rate. Now we have very low compliance, a little bit higher resistance. If I change again to a normal compliance, you will also immediately see the change on the ventilator and also on the simulator. If you go higher with the resistance, you will also see that the simulator is building up an auto PEEP. And depending on the respiratory rate I put on the ventilator, this will get worse and worse. And so I can manually go through these settings, and I can also start now spontaneous breathing. And what I forgot to show you, you can also split the compliance values in lung compliance and chest wall compliance. So if you want to be very, very accurate and want to do fine-tuning on these settings, you can split those and then you can adjust them separately. And the same goes with the resistance. If you want to split the resistance, you can also put the inspiratory and expiratory resistance differently. You can also change the way of compliance is implemented in the alveo, a linear compliance, which is reproducible compliance used in most of lung simulators nowadays, but we can also put this into a regular S-curve shape. So now alveo is around 10K of alveoli mathematically modeled, and they open and close like a real lung, and they are shaped in a way a normal lung would open. And we can also do this with the resistance. We can do linear for laminar flows, for lower flows, but we can also do parabolic for turbulent flows. But I keep this for linear. And when I set the compliance to the S-curve, I can set some recruitability settings. So currently, recruitability of this lung, if I would do a recruitment maneuver, would be none. So we would see a non-recruitable lung. But we can also switch that to a good recruitable lung. So the behavior of the lung, especially during a recruitment maneuver, changes. If I go back to linear compliance, this will be grayed out because then it wouldn't make sense, because a linear compliance lung is a not recruitable lung. But I leave that with S. And later on, when we apply, we may do a recruitment maneuver. And here we can do some spontaneous breathing, so we can also have an in- and expiratory effort type. So if we want to do just an expiratory effort and mimic something like coughing or an active exhalation, we can do this manually. And here is the muscular time, so the inspiration time. We can set the rate of the patient, and we can also put a variation to this rate. So that means I can do a variation to the muscular effort, because no one breathes all the time the same like a robot. And we can also put a little variation to the rate so that the breathing looks more natural. And in terms of timing, you can also decide to model your timing to your liking. So you can also put in an expiration and do your own rise, hold, release pattern. And you can also do a profile for your special requirements. So this can be done with spontaneous breathing. And then we have the options. So we have leakage, is currently switched off, but I can switch it on, and then I can maybe put a little leakage, and maybe you look at the ventilator, what the ventilator is doing a leakage 37%, and apply this. And then you also can adjust the FRC. The FRC setting is possible from 10 ml up to 4 liters. And we may increase this later on, because since we are not limited to any tidal volume, because we are not conserving the air, we are thinking about, and we're currently also working with the veterinary university to really simulate large mammals like horses, and then we also would put up the FRC as well. But for a turbine blower, that's not much of an issue. So I apply all these settings. And now I'm going to the ventilator and will initiate, but I will change the settings a little bit here, initiate a recruitment maneuver. I think the compliance is fine. I will change the resistance a bit. So I now go to the ventilator itself. And you see, this is the recruitment screen. I did some recruitments before today. And now we have set, let me just check, the whole thing to good recruitability. So we should see an S-curved shape and quite an hysteresis. So let's just start the maneuver. Okay, we can identify inflection points, like here. We may model them a little bit more visible on the good one. And if you go, for example, and there are, I don't know how many indicators are there to indicate that it's a recruitable lung. So there is the hysteresis and the amount of, or the maximum hysteresis, and you can also see on the screen that there is a 500 ml of hysteresis volume. So from most people who are using this for sustained inflation maneuvers, everyone would probably agree that this looks like a recruitable lung. And now the second part, which is really interesting, but we have to wait for a second. If we do a recruitment maneuver, this was an assessment, so we now know this is a recruitable patient. Now I can do a recruitment maneuver, and I have a recruitment, so I have a hold time after the inflation. And what alveo does, it really accounts this hold time as well and opens alveoli in this time. So you would see, and this is indicated on this ventilator by a blue bar at the end of the inspiration. So now alveoli pop out, and then it goes back. And you would also see the recruited volume after this. So not much has happened. Maybe there's also a little bit of leakage there, but you can also see the recruited volume as well. We have tried several recruitment maneuvers coming from different ventilator manufacturers. Some have kind of a staircase maneuver. Some are using a sustained inflation or low flow maneuver. So we are counting to this, and over time we will also refine the behavior of alveo. But having a viscoelastic model will allow us to really react to this, and so also put it in the physiology, so that a successful recruitment maneuver will also make some changes in terms of saturation and CO2 elimination on the physiology as well. If I adjust alveo now for a non-recruitable lung. So I just go back, change the recruitability to none. And I will do another assessment with a non-recruitable lung, and you will probably and hopefully see the difference. So you already see that there are no identifier inflection points. There is no hysteresis. So this is what would look like a non-recruitable lung. And we didn't connect it directly to the lung condition because there are also some moderate ARDS which still have a good recruitability, and there are also moderate ARDS which have no or very, very few recruitability. So this is really a little bit separated from the lung condition. So you can also show that this, or you can adjust that this patient may have a moderate or severe ARDS, but still has some recruitability potential. Okay, let's go back to the tablet. And we put this off again. Go back to linear here as well. And then you also see that the current settings here are down here. So you see that is always my compliance. This is the compliance of the respiratory system, the inspiratory resistance, O2, we come to that in a minute, and also the muscular effort. So if I change now, for example, the settings on the ventilator to a spontaneous mode, and go back to the spontaneous settings, I set a PMAS, and then I can also have an inspiratory time, and then I can also set a rate, 15, 5, and if I go back to the ventilator, you see now that the spontaneous and the triggered breath or patient-triggered breath are shown as shaded curves. So we now see that the patient is breathing or triggering the ventilator itself. So this is the spontaneous breathing. And if we want to adjust here the inspiratory time or the effort, so we can also make a larger effort here of 20, for example. And then the patient effort will get much higher. Or we have a very, very low effort. And if we adjust the triggering on the ventilator, for example, we might get asynchronous events. Triggering is still good. We can go to 0.1 effort-wise, and then probably not every breath will come through. So we have to adjust the trigger again. We have an auto trigger. So a little bit. Lot of things you can now adjust and work with. And using the tablets is currently displaying all this, but all these values you can see, and you will see in a few days, and we will also upload the final technical specification this week. They can also be taken out of when you directly connect it to a PC over the interface. So you get the full feature set and also monitoring set also via PC. But currently in the initial version, we mainly display the settings there. But they can be also retrieved from the simulator directly. Okay, so I have to do a little switch. I will just show the ventilator for a second. And now I will show the physiology model of alveo. And I have adjusted, couldn't show you this, a mild ARDS patient, normal weight, normal height. And when I go back to the tablet, I can show you the vital signs here, and I will restart ventilation again. So you see the vital signs, you also see the lungs. So there are different layers on the lungs. So the trachea is free, is not restricted. So that means the resistance is normal. But there are some layers in the lung which indicate that the lung compliance is lower than normal. We have up to 3 layers. So it's not the maximum, but it could be better. And when there would be spontaneous breathing, you would also see the diaphragm lighting up. But I can also put this back. But now you see the patient in terms of SpO2 and CO2 is not really well. And what I also did to show, just to make it quick, I put the PEEP to 0. And now you see that the SpO2 will even deteriorate faster. The one thing we couldn't manage for today, it was meant to happen this week, is that you can also either, when you ventilate with a ventilator, and this ventilator is connected to oxygen, you can adjust the oxygen on the ventilator, and then alveo will measure the incoming oxygen concentration, and this will be accounted also for the respiratory physiology model. And but if you don't want to waste oxygen just for simulation training, you can also adjust the oxygen virtually. So you have to do this in the configuration menu. Is it real oxygen going or running through the system, or will it be virtual oxygen? And I think the first thing you would do for such a patient is increase the oxygen. I can do that, I can show that, but it's not connected to the model right now. But this would, I think, be the first thing to do. And what I can do now is just show by going up with the PEEP, for example, and this drastically, that most probably, just to make this happen quick, and also adjust the pressure support and the rate a little bit, that the desaturation will be stopped and patient will start to get better on saturation. And this is autonomous. So whatever you do on the ventilator, when you're doing good, the whole physiological system is reacting to this input, is reacting to the increase of mean pressure, to the decrease of mean pressure. So this is all something you are not able to influence directly. You will be able to change the severity of the pathology you're having. So when you're starting with a mild ARDS, you can later go back to what we call incidence. You can make an apnea immediately. You can also change the severity. So all these buttons are not finished yet. You can also throw in an acute asthma or pneumothorax. That will be possible as well. But you can also start spontaneous breathing. You can stop spontaneous breathing. You can make an exhaustion from a patient. So this will be all possible via these incidence settings. And as soon as you have initiated an incident, for example, apnea, but the patient is not breathing anyway, you will see on top that this incident is in progress. So the student will just see the vital signs, and he won't see that you have initiated an incident. But now the incident is active, but you can also always stop the incident, and then it goes back to the prior settings. So when you want to change the severity of your condition, you can do this via the incident. Going back to the patient, so the saturation is rising slowly because we do not have any additional oxygen right now. So this will take a while until patient gets healthy again. And we also see that the rate or the heart rate is really high. So I think additional oxygen would help. And I'm really sorry that I can't show this today. But the whole system will react to the inputs of the ventilators. In the launch version, we will only cover respiratory cases, but later on, this model also has drug application integrated, so we also may add some drug application as well. And you can also see ABG values on the fly. This is dynamic. Also the metabolism, like the CO2 elimination, and also the oxygen uptake, and also the VQ and the shunt will also be shown in this. But if you're really mean to your student, you can also deactivate this. So he really has to just look at the vital signs, and then he has to find out what the issue and what the problem is. He has to look at the waveforms of on the ventilator and also on the waveforms of the simulator and of the vital signs of this patient. Okay, I think we are ready, and unfortunately, and I could probably talk for hours, to stop the simulation, and we are ready for the FAQ. Probably we have quite some, and I've seen that some may already have been answered, but if we can't answer all of them in time, we will write you an email, or this video will also be available with a registration link or with a link, so you can also get additional information on your questions we couldn't maybe answer. There's one question. Are the generated parameters, lung condition, presence, ARDS, COPD backed by clinical studies? Yes, but unfortunately, and we made quite some research about this, this is, of course, when you have a setting of a COPD, there are guidelines, the GOLD guidelines, for example, and they already tell by some parameters how this lung will look like, or what this patient has to endure, and what the condition of the lung is. And for ARDS, we also have the Berlin definition. So we know a little bit about the condition of the patient and the setting, the compliance, but also the compliance is not a fixed value, because the compliance for an ARDS patient of a patient which is 1.50 meters might be different than the compliance of a patient who is 1.90 meters. So it's not a fixed value. You can take from a study and say, okay, this is a moderate ARDS, or this is a moderate COPD. So we are looking at all guidelines and studies we could get a hold of, but there is unfortunately not many who will just tell you, okay, a moderate ARDS is setting ABC. That's unfortunately not the case. But this is, I think, and we also will publish a very long list where we got our values and settings from. But of course, if you're not happy with the presets we are making, you can still adjust your same profiles and then start from this point. So this will be possible too when you're not entirely happy. And I'm quite sure whatever we've put up and how many effort we put up into making these preset settings. There will be probably people out there who are not really happy with those and would like to change this anyway. The accuracies of measurements, we will announce the technical specification sheet if you're registered to the alveo website. This will be downloadable, I think, by the end of the week. So then you can see all the accuracies we have for compliance, resistance, and all this will be available there. The muscle pressure profile can be freely defined via scripting. And I will defer to Matthias if we can just unmute himself, because this is a part which is covered by our engineers. What is the scripting part here? Maybe Matthias can speak to that.
Hi, everybody. There will be a scripting interface, a serial interface, where you can set all these values without the tablet. And it is planned to have the muscle pressure profile as a setting as well, where you can just set the current value. You want like 2 millibar muscle pressure at this exact time. I'm not entirely sure if this is planned for the initial release, but it certainly is planned for the future. Yeah.
Another question is, can alveo deal with HFO ventilation? Yeah, we can say yes. We can measure up to 33 Hertz. So it's 2000 strokes a minute. And recently we had this on an exhibition in Singapore, and it was connected to and we also tested this here, was also connected to an HFO. This works. Would also be possible to do recruitment on these lines. But the neonatal software, because we're starting with pediatric and adult, we will add later on an advanced version of the software you saw today for research, for benchmark performance testing. So there will be additional software upgrades coming. And also the dedicated neonatal software will be available also, I would say, in the first half of next year as well. What about ETCO2? Yeah, this is something we are also thinking about, that at the end of the day, in full bloom, alveo will be able to also consume O2 and give back CO2. This will be probably done, but we don't have a timeline for this for now, with an additional module, so that you can instill CO2 and then also put this back, especially when you have closed loop ventilation. This could absolutely make sense, and also for some measurements. It's in the books of requirements we have, but we do not have a timeline, but we will take care of that for sure. How often does alveo need to be calibrated? So alveo, when starting up, is calibrating itself, but if you follow our recommendations, there will be an annual calibration in our calibration labs and on maintenance. We currently offer for the first batch an additional year of guarantee and 1 calibration and maintenance for free. But for the upcoming years, an annual calibration and maintenance is recommended. And this will be also certified via ISO 17025 or is accredited. Okay, we have already answered these questions. So we have some new posts and new questions. Ambient condition, can the alveo work? Pressure, temperature, humidity. I don't know the numbers by heart. I will defer to watch for the announcement that the final technical specifications are uploaded, and we also have this in the spreadsheet or in the table or in the brochure as well. Yes, alveo represents flow in different gas conditions. This can also be seen on this spreadsheet as well. As far as I can see, let's just check the chat for a second if there are any questions in the chat. Okay, so, but we also have the info at alveo simulator address, so you can go via our website. You can write us directly to IMT Analytics, but there's also an alveo simulator if you have more questions, if you want to request a quote for the simulator. Launch will be starting by the end of October, then the first devices will be shipped. We have the special launch edition with a special discount and additional guarantee. But if you have any further questions, any questions about the physiology which is working in the device or other settings, we are just at the start. We will launch in October. This is the start of the alveo journey. There will be software upgrades over time and very soon. So it's a future-proof device. There will be modules, there will be enhancements. So you do not have to buy another device next year because we just added neonatal. So this will all be done with this device we discussed today. So if everyone's happy, I think we're about time. All the questions seem to be answered. There was a question about the simulated slow flow PV loop. I demonstrated this. And shortly before launch, we will do another webinar and maybe go a little bit deeper into the possibilities. This was just the first announcement, the first webinar about alveo, so you know what this simulator is capable of. But I will be really excited to show all of the rest, which will be implemented then shortly before. So thank you very much for participating. I'm really excited about this. I hope you too. And if you have any questions, just contact us. And thank you so much. And have a good day, good evening. Bye-bye.